Hello everyone, welcome to my channel. In this video, I will explain about Markov Chain Monte Carlo methods. So in short, we called as MCMC. So this topic belongs to machine learning. First we will see the definition about the Markov Chain Monte Carlo method. So you observe the definition first. So what is a MCMC? Markov Chain Monte Carlo is a method used to sample from the probability distribution when direct sampling is difficult. Okay, when the direct sampling is difficult, we are using this method. This method is called as MCMC. It works by constructing a Markov chain that moves step by step through possible values and generate samples over the time. Okay, how this MCMC will work? So it works by the constructing a Markov chain. So we are going to construct here Markov chain that moves step by step through possible values generating samples over the time. So this is called as what we say MCMC. So we will see the next step. As the number of steps increases, the generated samples gradually approximate the true target distribution. So remember all of you, when there is a Markov chain Monte Carlo, we can also say MCMC. So there are two important mechanisms are there. So first mechanism is called as Monte Carlo method, and second one is called as Markov chain method. Okay, so first one is the Monte Carlo, second one is the Markov chain. So let us discuss about the Monte Carlo. So what is this Monte Carlo method? The Monte Carlo method is a technique that uses random sampling to solve mathematical and statistical problems. Okay, so in order to solve mathematical and statistical problems, we are using the concept called as Monte Carlo method. It is used to estimate the probabilities and expectations when the exact calculation is not possible. Okay, when I don't know the exact calculation, we can prefer the concept called as Monte Carlo method. So let us see the diagram related to Monte Carlo method. So you observe there is a graph is there on the screen. So this is called as graph. So it contains the dots as well as it contains some path. So you observe what is the meaning of this green dots. So green dots are represent random samples. So this represents the random sample, it represents the random sample and so on. So every individual green dot will represent the random sample. Okay, so it represents the probability distribution. So the green dots nothing but it represents the random sample, and green dots represents the probability distribution. So these green dots are called as, we can say, random samples. So second one is the zigzag green line. So you observe this is the zigzag of green line. This is a zigzag of green line. It is a zigzag of green line. It shows the MCMC sampling path. Okay, so this is called as a MCMC sampling path. So the path moves randomly but prefers regions with more dots, high probability. Okay, so there are a number of dots are there. Always this method will select the more number of dots. So which is also called as, we can say, high probability. It sometimes visits the low probability areas but return to dense regions. So over the time, the collected points approximate the true distribution. So this is called as what we say Monte Carlo method. So in the Monte Carlo method, what is going to be happened? We have given the green dots, which is called as the random samples. So we can say these green dots are called as random samples, and this line is called as the path. So it shows the how samples are collected step by step. So this is the path is going to collect the samples step by step. So this is called as the mechanism is Monte Carlo method. So let us see the example related to this one. Now you see Monte Carlo method example. To find the area under a curve instead of using complex integration. Okay, generally how to find the area of curve? We use some integration part. So instead of that integration part, we are going to use randomly place points, okay, green dots inside the rectangle. So inside the rectangle, we are going to give random dots. So randomly we place some points. Count how many points fall under the curve. Yes. So how many points are there under the curve? Then we are going to find out the ratio. So that is equal to point under the curve by total number of points into area of rectangle. Okay. So there is something called as rectangle is there. So what we are going to do? We are going to find out the example of area under curve. Okay. So when we find the area under the curve, what is going to be happened? There is a formula is there. The formula is called as here points under curve by total number of points into area of rectangle. So when you take more points, so this is called as what we say more accuracy. So please remember all of you, when you select more points, you will get more accuracy. So let us go for a mathematical idea by using some integration part. So we want to compute the expectation. So when we want to compute the expectation, we will use this formula. What is this formula? S equal to integration of P of x, f of x, d of x is equal to EP of f of x. So this is called as a mathematical formula related to, we are going to find some expectation. So we are going to find the result. So but when we come to this Monte Carlo approximation, so this is called as the formula related to Monte Carlo approximation. So when we do some integration, this is one, but when we apply Monte Carlo, this is the formula. Now you observe what is the formula related to Monte Carlo approximation. So Sn dash is equal to 1 by n, sigma of I is equal to 1 to n, f of x power I. So what is going to be happen? Take many random samples and compute average. Monte Carlo method estimates complex values by averaging the results of many of random samples. So we take many random samples and compute the average. When it comes to Monte Carlo method, it estimates the complex values by averaging the results of many random samples. So generally, what is the Monte Carlo algorithm? So there are three basic steps are there. So first one is called as setup, and second one is called as generate random points, and third one is called as we apply formula. This is a formula already we discussed in the above. So finally we get the final answer. So in order to compute this Monte Carlo algorithm, we need to follow these 4 steps. So to understand more clear, we will take one problem. Now you see the problem is here, estimate the area under the curve y is equal to x square and y is equal to x square from x equal to 0 to x equal to 1 using Monte Carlo method. So what is the first step? In this first step is setup. Okay, so already we discussed here. So first step is setup. What we need to set up? When we have y is equal to x square, so let us assume width is equal to 1, height is equal to 1. So we will find the area of rectangle, that is equal to 1. Second one is the generate random points. So after completion of first step, we go to second step, we will generate random points. So assume that we will generate 10 random points inside the rectangle. Okay, so inside the rectangle, we are going to generate how many points are there? 10 points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Out of this, 4 points fall below the curve. So out of these 10, only 4 dots, okay, 4 dots fall below the curve. So these 4, let us say these 4 dots are fall below the curve. So this is equation is equal to y is equal to x square. Okay, so after completion of second step, we apply formula. So what is the formula? Area is equal to points under curve. So how many points are going to, let us assume here 4. So the value is equal to 4 and total points are 10. So this is equal to 0.4. Okay, so the final answer is estimated area, that is equal to 0.4 after completion of this algorithm called as Monte Carlo method. But we need to analyze whether this answer is right or wrong by checking with a mathematical notation. So let us see here, the actual value could be here 0.33, not 0.4. How we receive this 0.33? You can observe by using this mathematical equation. Now you see the equation given as y is equal to x square in the above. Yes, so this is equal to y is equal to x square. So when we do have y is equal to x square, there are two intervals are there, x equal to 0 to x equal to 1. When we use this integration about the area of rectangle, that is equal to integration of 0 to 1 x square dx. Okay, so when we apply this integrate, what is the formula? We know when we have integration of x power n is equal to x power n plus 1 by n plus 1. So this is equal to x power 2 plus 1 by 2 plus 1. Yes, that is equal to x power 3 by 3. Okay, so let us assume the limits are 0 to 1. Okay, so area is equal to x, this value, x cube by 3. So the values limits are 0 to 1. So when we apply 0 to 1, this x value will be changed as 1 first time and x value will be changed as 0 second time. So the final answer is 1.1 by 3 when we apply the concept called as mathematical notation. Okay, so when we apply this concept that is Monte Carlo, we have the result is 0.4. But what is actual result? The result is here 0.33. Hence, what is the conclusion here? Error is due to small number of samples. Okay, so we received some error because actually we need to get the answer called as here 0.3. But what we received? We received the answer as here. We received answer as 0.4. So this is called as what we say error. Okay, so this error came because of small number of samples. So when we increase more points, we will get more accuracy. Increasing the number of samples reduce the errors and improve the accuracy. So Monte Carlo estimates area, random sampling and ratio of points under the curve. Okay, so this is called as what we say the example related to Monte Carlo method. So this is equation what we have, this is equal to 0.33 but we received as 0.4. Now let us go for second concept. This second concept is called as Markov chain method. So what is this Markov chain method? Markov chain can be understood as a process of moving step by step through states where choice of next state depends on only current state. Very important. So it depends on only current state and the probability distribution of next states. So remember all of you, in this the future state depends on only the current state. Very important point. Okay, and it is not depend on the past states. So in order to better understanding this Markov chain, so we have some diagram is there on the screen. Now you observe here the diagram consists of 4 number of states. First state is rain, second state is car wash, third one is wet ground and fourth one is slip. What is the meaning of this diagram? This diagram shows the how one state leads to another based on the probability. You observe when there is a rain, okay, or car wash. So if at all there is a rain as well as a car wash, it leads to wet ground. The ground is going to be wet. So because of rain as well as car wash. So we can, when the ground is wet, okay, when the ground is wet, what you have to do? It may lead to slip. So this is called as the example for Markov chain mechanism. So let us see what is the mathematical equation for this Markov chain method. So this method is called as, this example is called as Markov chain method. So here the example formula is this one. Okay, so this is equal to P of xn plus 1 by xn and so on. So this is called as Markov chain method. So last one what we have on the screen, that is third one, Markov chain Monte Carlo. So remember all of you, when you say Markov chain Monte Carlo, it combines two. First one is the Markov chain, second one is the Monte Carlo method. So in the Markov chain, we do step by step movement when the next state depends on only current state. But in the Monte Carlo method, we are using random sampling method. So this is about the Markov chain Monte Carlo method. So remember, it consists of completely three states are there. So first state is called as current state, and second state is called as proposed state, and third state is called as next state. So what is going to be happened in this states? So you observe, when you have this current state, this is the starting point. Okay, so it is called as starting point. So second one is the proposed state. A new state is generated from the current state. Okay, so you observe here, in this new state is how using current state. Okay, so new state is, you can observe here, a new state is generated from the current state. So new state is generated from the current, from this new state will be generated. So that is called as what we say proposed. Last one is the next state. So remember all of you, when it is have two things. First one is the accept, second one is the reject. When it is accept, it goes to next state. Okay, if it is reject, it goes to again current state. So this is called as Markov chain Monte Carlo method. Okay, so this is about the Markov chain Monte Carlo method. So I will see how this Markov chain Monte Carlo works. So there are completely 8 number of steps are there. So first one is a start with initial value, second one propose a new value randomly, third one compare new with current, fourth one if it is better accept, otherwise check some probability, repeat 2 and 5, ignore first few samples, and last one is the collect remaining samples as a result. So let us see, same, this is a flow chart related to this MCMC. So just you observe this one. Now this is an important point. We will go for the algorithm. So this is a algorithm steps. Now we go for the problem related to the above algorithm. Now you see the first value here, you observe, let us say the initial state, it is going to start with 2. Okay, so when you have 2, next the proposed, so I am going to visit the next one as 4, it is accepted, because you observe here, what is the meaning of if it is better, you accept, otherwise you may not accept. So if not, you accept with some probability. If you see, observe here, I am going to have 2 value here. If you take 4, so 4 is bigger than 2, then you can accept. Okay, so 4 is better, we can accept. So we accepted. Next new state will become now 4. Okay, so next propose x dash is equal to 1. So now I am going to propose the value as x dash as 1. So compare. Now 4 with 1. So 4 is greater than 1. So 1 is very smaller than 4. So what you have to do, you need to ignore this one. So that's why I removed this one. Okay, now what is going to be happen after completion of this one? So 1 is rejected, so you need to stay 4 only. Okay, so after completion of this one, so what is going to be happen? First start with 2. Okay, and then proposed state is 4. Okay, so if you compare this proposed state is 4, it is better, then you accept. Now the new state will become 4. So this is called as new state. Now what will be happened? We need to compare, the proposed state is 1. So when you compare with 4, what will be happened? The value is more, 4 is more greater than 1. Just you kindly ignore this one. Then what you have to do? After completion of 4, let us take 3. Okay, so let us take 3. So when you take 3, even though 4 is greater than 3, but what is telling in this one is telling with some probability. Okay, accept with some probability. Now you observe, when there is a state is 4, current state is 4, and proposed state is 3. So just we need to find out the value called as proposed state divided by current state. So that is equal to 0.5. If it is less than 1, we will accept. Okay, so that's why I can go with the 3. So now the proposed state is this one. So the value is, here we have 3. So similarly, we can go for 5 as well as we can go for 4. Okay, so when I at 3, so 3 I can go for 5 because 5 is bigger than 3, no problem. But when it comes to 4, so what is the next value? 4. So when it is 4, what we have to do? So we need to divide with the proposed with the current. So this is equal to 0.8. So again it is less than 1. So we will accept. So this is the final path. Okay, so this is a way to calculate the MCMC. Next, last one in this, you need to add this topic also in the writing the examination. This is a very, very, very important. So last one in the MCMC, that is equal to Metropolis-Hastings algorithm. So it is a MCMC algorithm used to generate samples from the probability distribution by processing new states and accepting them based on the probability. Okay, here we will focus on probability. Now you see the algorithm. So completely there are 6 steps are there. Start with initial state x. Second one, propose a new state called as x dash. Then we find the ratio, that is equal to f x dash by f of x. Accept rule. So what is this one? If r is greater than or equal to 1, accept x dash. Okay, if r is less than, accept with some probability. And fifth one, if it is accepted, move to x dash. And last one is the repeat many times. Okay, so in order to better understand, we'll go with the problem. So what is Metropolis example? Okay, so here they have given some equation. The equation is f of x is equal to x square, and the current state is x equal to proposed state. So I want to go with the next state as 4. So I have to, next I want to go with the 4. Now what is going to be happened? So compute the values first. So how to compute this value? When the equation is x square, so what is the value of 2 square? 4. 4 square? 16. Now we will find the ratio. So how to find this ratio? So that is equal to f of 4 by f of 2. So this is equal to proposed state by current state. So the answer is 4. Okay. So now we will go for the step 3. So what is step 3? What is the value of r? r is greater than 1. So what is the value of r? 4. This r is called as 4 is greater than 1. Yes. So what is the condition here? If it is greater than 1, accept. Okay. So this is called as accepted. Then we move from x equal to 2 to x equal to 4. So after completion of this 2, directly we go for 4. Okay. So this is called as a Metropolis algorithm. So this is one of the most important question in the examination. This is called as a MCMC 100% question will ask in the examination. Kindly prepare everyone. This is called as Markov Chain Monte Carlo method. Okay. Thank you for watching this video. Please subscribe my channel. Thank you. Please like it.